All right, so let's talk about the Nernst equation, which is written here. And this is just a general electrochemical expression that's relating the potential to the concentration or activity of species at a temperature. And at 25 degrees Celsius, the equation can be rewritten like this. And you might also see the natural log form of this equation, which is written over here. So to see how this equation works, let's go through an example. So in this electrochemical system, we have aluminum reacting with manganese 2+ to produce aluminum 3+ and manganese solid. And the standard cell potential for this reaction is 0.48 volts, but we have a concentration of manganese 2+ as 0.5 molar and aluminum 3+ as 1.50 molar. So let's start off first by looking at the half reactions, which are going to be rewritten over here. And the first thing that we see is first N equals 6 because we see that there are 6 electrons being transferred. And the second thing is that aluminum is being oxidized while manganese is being reduced because it's gaining these electrons. So then let's go ahead and plug and chug for this example. So here is the Nernst equation as written over here, except we've plugged in 6 for N because we found that out over here. And then for the next part, we need to plug in the numbers for Q, which if you remember is equal to products over reactants. And in this case, we'll go ahead and take the aluminum 3+, and we'll take this 2 coefficient and we'll raise this concentration to that power. And then for this manganese, we'll go ahead and we'll take the manganese 2+ concentration and we'll raise it to the power of 3 because that's the coefficient that's over here on the reactant side. And then all we have to do is really just plug in these 2 numbers and then solve for Q, which gives us 18. And if you go ahead and just solve this equation, you get that the cell potential is going to be equal to 0.467 volts.